All right, guys, so now we're going to step our game up a little bit. We're going to get into the part of the course that deals with something called exponential functions. Okay, so up to this point, we've only dealt with equations and functions that look like straight lines, lines that go straight up and to the right, straight down and to the right, straight up and down, or straight across, okay? However, as we get further and further along in this course, we're going to deal with things that are a little bit more complicated, and the first one we're going to introduce is called an exponential function. Okay, what are exponential functions? Exponential functions follow the format of this equation. Okay, the equation of an exponential function usually follows the format of y equals a times b raised to the x power. Okay, most of you guys are familiar with y is equal to mx plus b. Y is equal to mx plus b is meant for things that are straight lines, but this is not a straight line. This is called an exponential function. It's going to look a little bit different, okay? But what do you need to know about this equation? The first thing is this. A and B are numbers, but A is not allowed to equal 0. Okay? A is a number, B is also a number. That number, the second number, B, has to be greater than 0. The number that's attached to the exponent, in this case it's the letter x, has to be greater than 0, but it also cannot be equal to exactly 1. Okay, so it can be a decimal between 0 and 1, or it could be a number that's bigger than 1. It just can't be exactly 1. Okay, a couple other things about these numbers, A and B. The base is a constant. Okay, what a constant means is it's just a number. We've said that over and over again. And the exponent is a variable. Okay, in this example, with the way I wrote this equation, this letter up here in the exponent is always going to be a variable. Typically, it's going to be the letter x. Okay, but here's the biggest takeaway. Exponential functions, what we're talking about today, exponential functions are what we call non-linear. They are not straight lines. Okay, so let's do a comparison. Let's look at something we know and compare it to this new thing that we just learned about. So if I asked you to graph the equation y is equal to 3x, okay, this is something we have done before. This equation right here follows the format y is equal to mx plus b. And what do we know about equations in this format? They are linear functions. Y is equal to 3x is a linear function. Okay, so let's start off by graphing this. Let's do a little bit of a review. And if you guys remember when you first started graphing, when in doubt, if you didn't know what something looked like, the best method to graph something would just be by making an input-output table. Plug some numbers in and get some numbers back. Okay, so here's what's nice about graphing. Okay, you can plug in whatever numbers you want into that equation. You want to pick the easiest numbers possible. So here's what I'll always say. When you're trying to graph an equation, let's start with the easiest number to plug in. Okay, what is the easiest number to plug into this equation? It's probably the number 0. So if I plug in this number, 0, in for x into that equation, I'd get something like y is equal to, and wherever I see an x, I'm going to plug in a 0 to get my first point. 3 times 0. Okay, so what do I know? When I plug in the number 0 in for x, what do I get back for y? Well, 3 times 0 is equal to 0. When I plug in 0, I get back 0. So what I know is that 0, 0 is one of the points on this graph. And let's plot it. 0, 0 is right here. Okay, now I ask myself, what's the second easiest number to plug in? Okay, 0 is the first. 1's pretty easy as well. Let's plug in 1 into this equation. So if I get y is equal to 3, and then for x, I'm going to plug in 1. Y is equal to 3 times 1. 3 times 1 is equal to 3. So when I plug in 1 into this linear equation, I should get back a 3. I know that the point 1, 3 is on this line. So I plot it. 1 unit to the right, 3 units up. This is a point on this line. And let's get 1 or 2 more. Okay, if I plug in 2, what do I get back? So y is equal to 3 times 2. 3 times 2 is equal to 6. When I plug in 2 in for x, I should get back a y coordinate of 6. 2, 6 is all the way up here, it looks like. Okay, Typically, it's a good idea to get some negative numbers as well, just to get a better idea of what it looks like on both sides. If I were to plug in -1 into this equation, 3 times -1, I would get back -3. So I know the point -1 comma -3 is also on this line, which is way down here, but it's off the grid, so I'm not going to spend a ton of time worrying about it. And if I were to plug in -2, I get back -6. -2 comma -6 is way down here. Okay, so a lot of work, but I know if I was graphing this linear equation, it would look something like this. It's a straight line going up and to the right. This is something we've done before. Okay, we've plotted things in the format y is equal to mx plus b. Now, let's talk about this new type of equation. This is called an exponential function. Okay, exponential functions follows the format of y is equal to a times b raised to the x power. Okay, but we could also say this is a nonlinear function. It doesn't follow the format y equals mx plus b. Okay, why does this follow this format? Okay, well, the number attached to the exponent is b in this case is 2, and then a, even though we don't see a number here, a is equal to 1. So I'll write that to the side here. A equals 1, and then b equals 2. The number that's attached to the exponent is b, a is the number in front of it. Okay, so now, what we're going to do is to figure out what this thing looks like, we're just going to plot some points. We're going to plug in some values for x and see what we get back for y. So I ask myself, okay, what's the easiest number I can plug into this equation? 9 times out of 10, it's always going to be the number 0. Let's plug in 0 and see what happens. If I plug in 0 in for x, I'd have 2 to the 0 power. Okay, so what do I know? Anything raised to the 0 power is going to spit out a what? It's going to spit out a 1. So when I plug in 0 into this equation, what do I get back? I get back 1. So what do I know? I know that the first point I'm going to have on this exponential function is the point 0, comma 1, which is right here. 0 units to the left and right, 1 unit up. Okay, what's the second easiest number I could plug in? Probably 1. If I plug in 1, I'll have 2 to the first power. Okay, 2 to the first power is equal to 2. I know that when I plug in an x coordinate of 1, I get back a y coordinate of 2. Let's plot it. 1 comma 2 is right here. Okay, looking pretty similar to the linear function so far, but let's keep going. Okay, 30 is the easiest number I could plug in. Let's try 2. Y is equal to 2 raised to the second power. Okay, 2 to the second power is equal to 4, so when I plug in 2 for x, I get back a 4. And where's that at? 2 comma 4 is all the way up here. Okay, so a little bit funny looking. It's not a straight line. We notice it's kind of got a little bit of a curve to it. But let's get some points on the other side. Let's get some points to the left of 0. So let's plug in -1 for x and see what happens. If I have 2 to the negative first power, okay, using my exponent properties, what is that the same thing as? Well, it's the same thing as 1 over 2 to the first power. And what is 1 over 2 to the first power? It's the same thing as 1/2. Okay, so here's what's weird. When I plug in -1 into this equation, I get back 1/2. A number that's still bigger than 0. It's still positive, but it's a little somewhere between 0 and 1. So when I plug in -1, it should be right about here. Halfway between 0 and 1. Okay, it's got a little bit of a curve you're starting to see, but let's get one more point. Let's plug in -2. If I have 2 to the negative second power, it's the same thing as 1 over 2 squared. 1 over 2 squared is the same thing as 1 over 4. When I plug in -2, I should get 1/4. Let's plot it. -2, comma 1/4 is way down here, super, super close to 0, but just above it. Okay, now, when I connect the dots here, what is this thing going to look like? Basically what's going to happen is this line is going to hover above 0 the entire time, but never actually cross it. And then all of a sudden, it's going to just shoot towards the sky. Okay, it's got this nice little curvy thing going up and to the right. Okay, this is called an exponential function. Notice it is not a straight line like a linear function. This is what exponential functions look like. Start off super flat, and then all of a sudden, once they cross a certain threshold, they start spiking up towards the sky.